All right, science gang. The last time we met, we looked at the part one version of polyatomic compounds, did a few formula writings. Let's look at the remaining ones. I think in the last video I recommended you try these ones. So let's see how you made out. So iron 3, first of all. So that's relatively easy. Iron 3, we're told which version of iron we're using because it's one of those transition metals. There's more than one option. Iron 3. And then hydroxide. Hydroxide you can see is right here, OH minus. So we'll write that out there. Grab my, once again I'm moving things around like a crazy man here. Let's get that right. So OH minus. So you can see this doesn't work. 3 positives, 1 negative. That doesn't balance out. So we're short of hydroxides. We're going to have a total of 3 negatives here. Since each one is 1, that means, of course, we're going to have 3 of these. So if I have 3 of those suckers there, we can see that 3 positives, 1, 2, 3 negatives, that'll balance out perfectly. So the final formula, summarizing what I just did there, 1 iron, 3 hydroxides, so I have to put a 3 over here. A common mistake that people will make is that they'll leave it like this. And this technically tells me that this 3 is only applying to the H, but I want it to apply to the whole OH group. So whenever you have to have more than one polyatomic ion, you have to use brackets to illustrate that that subscript applies to the whole part of that polyatomic ion there. So there we go. Iron 3 hydroxide. Oops. Wrong marker there. There we go. There's my yellow highlighter. Don't leave home without it. Iron 3 hydroxide, Fe, start bracket, OH, and bracket 3. 3 hydroxides for every 1 iron. Okay? Last one here, nickel chlorate. So if we go back a couple of pages here, grab our nickel there. Nickel is 2 positive. And once again, I'll try to get this all in one sheet so you don't have to go back through 2 booklets or whatever. Nickel, 2 positive. There we have it right there. Chlorate. If we go up here, look for chlorate. Chlorate, chloride. ClO3 negative. LO3. I'll grab my negative from up there in the top left corner. It always mysteriously appears there. So of course this doesn't balance out. We have 2 positives, 1 negative. We're short of chlorates. If we were to get a total of 2 of them, that would balance out perfectly here. So I'm just going to add another one. I can never stop doing that. So there we go. Nickel chlorate. There we go. 2 positives, 1, 2 negatives. So the formula is going to suggest that I need, for every 1 nickel, I need 2 chlorates. So ClO3. So once again, chlorate is ClO3. That 3, it's 1 chlorine and 3 oxygens, so it has to be there. But I have to illustrate that I need 3 of those big groups. So I put my little 3 here. Of course, it looks like a 33. So what that means is that, once again, I need a set of brackets to illustrate that that 3 is applying to the whole chlorate group. Once again, the rule of thumb, if you need more than one polyatomic group, you have to use a set of brackets to illustrate that. So there we go. So writing the formulas is a little more complicated than vice versa, given the formula and writing the name, which is what the next page is all about. So if you look over here, writing names, the key thing here is to identify what you have. So here, you can see we have this Na. And if you have something in brackets, that's what you're looking for. If there is no brackets, you're just simply looking at the whole section here. So sodium is the first element. And the second element, SO4, if you don't remember what that is, go back over here. SO4 is sulfate. So sodium sulfate. That's it. That's all you have to do. And you may be asking yourself, well, why is this little 2 here? And the reason why is because, if you recall, sulfate is 2 negative. And if you look back at sodium, sodium is 1 positive. So I needed to have 2 sodiums to balance one of those sulfates. So that's why the little subscript 2 is there, to illustrate that I needed 2 of those sodiums to balance a sulfate. That's it. If you look at the next one here, Ca, and then, oh, I have something in brackets here. It's this. So if you don't remember the names here, go back in your periodic table. Ca, of course, is calcium. And OH, if you don't remember that one, OH, hydroxide. That's it. And of course, why do we have this 2 here? Calcium, if you look back, is 2 positive. Hydroxide is 1 negative. So we need to have 2 of these to balance one of these. That's why we have that 2 there. Okay? Moving on here, let's take a look here. We have a PB. And we have something in brackets. Let's just be concerned about what's in brackets there. So PB, if we look back, now this is a tricky one because lead is one of these. So don't be led astray and pick the wrong one, because there's 2 different possibilities for lead, 2 positive or 4 positive. We have to figure out which one is it we're using. Is it 2 positive or 4 positive? So I'm just going to write that here. Is it 2 positive or 4 positive? We don't know at this point. The key here is to look at what it's paired up with. Nitrate. Nitrate. If you look back, nitrate is 1 negative charge, and it looks like we have 2 of them. So 1 negative and another 1 negative would give me a total of 2 negatives. So we know right now that that lead must be 2 positive. Because if we have 2 negatives, each lead, there's only 1 lead here, so it must be 2 positive. So it's that version. So you have to do a little bit of work there to figure out which one we're dealing with. So lead 2 nitrate. So you have to do that when you're dealing with a polyatomic, or sorry, a transition metal, one of those metals that has more than one option. Okay, moving on, we'll look over here. Mg, looks like we have 3 of them there to balance it out. And PO4. Now, if we look back in the chart, we'll see that magnesium is 2 positive. The phosphate group is 3 negative. So to make these work out, of course, the lowest common multiple at 3 and 2 is 6. So 3 times 2 is 6. 2 times 3 is 6. So that's why we have those particular subscripts there. 3 magnesiums will give me 6 positives. 2 phosphates give me 6 negatives. So that's why we have those numbers there. So you can just kind of do that to figure out, okay, what are the subscripts? But you know what? When you're just simply naming, you don't even have to worry about that. Just identify the ions that you're using, and then that's it. Magnesium phosphate. Last 2 here, we'll take a look. SN, if we look back, that is going to be tin, but once again, it's one of those ones that has more than one option. If we go back here, tin, we have, it could be 2 positive or 4 positive. So we're going to have to figure out which one is it, 2 or 4. We'll be the judge of that. So 2 or 4, I'm just going to write that down. So I know it's tin. I don't know which version it is though, so I'll just leave my brackets there. And we can see here that it is combined. Now it's not in brackets, so we can just highlight the whole darn thing here. SO4. So if you recall what that is, or if you don't recall, SO4 is sulfate, and it's 2 negative. It is 2 negative. And you know what? It looks like we only have one of them. One of these balances with one of these. So if my sulfate is 2 negative, my tin has to be 2 positive. So it's tin, Roman numeral 2, sulfate. It's got to be that version. Okay? So once again, transition metals, there's just a little bit more work there. You have to actually figure out which version you're using there before you figure out the name. Lastly here, we have K. Okay. And then we have, so you can see here, I'm just getting the first metal. So I know the H doesn't pair up with it because I'm just simply looking at the first element. And then HCO3. HCO3. So K, if you don't remember that, it's potassium. It has a positive 1 charge. And HCO3, HCO3, bicarbonate, or you can call it hydrogen carbonate, doesn't matter. So I'll just pick one of them. Bicarbonate. And this is one positive, this is one negative, so that's why we have one of these combined with one of these. They balance out perfectly. So there you have it. That's naming. On the bottom of the sheet I have some common acids. You're not going to be responsible for knowing how to name them. Just simply identify them. HNO3 nitric acid, HNO2 nitrous acid. We'll leave that for next year when you take Physical Science 20. We'll look at the naming scheme for that. So the assignment is on this page. If you see an acid, so for example, let's see here, nitric acid, carbonic acid, just simply grab it from the previous page here. Okay, so just simply grab the name there, or the formula there. And then at the bottom part, it's vice versa. If something begins with an H, HNO3, H3PO4, that also is an acid. We're going to take some acids and bases. Later on in the chemistry unit, we'll see how that works. So once again, just use this table. Here are the formulas for the acids. And then, of course, over on this side are the corresponding names. Okay? So have you work on this assignment here, having a little bit of practice learning what we just looked at here. See you next time.